And we're live. Welcome back, everyone, to another episode of Adventures in DevOps. Hosting today with me is Jillian. And Jillian, are you looking forward to today's episode? Did she freeze?
I did freeze for a few seconds, but I'm
Oh,
back
you're
now, so
muted.
I'm gonna assume that I'm gonna say hi here. Hi, everybody. I hope I don't freeze again, but I don't really know what just happened.
Yeah, I mean, when we planned this episode, I had a strong sense that this was going to be a popular choice for you, and that's because today I want to invite Barzan Mozaffari as our guest, MIT alum and University of Michigan associate professor, working with data-intensive systems for over 15 years. Welcome.
Thank you so much. Great to be here with you.
Yeah, I've worked in a lot of engineering organizations, and data has always been this aspect of an area that no one wants to touch. There's stuff going on there, and I just always seem like there's bigger business problems that are at play, or there's other challenges present, but I always got scared when the topic of interfacing with one of the data teams comes up. And I noticed from your history, your profile, there's a lot of different aspects of data systems that you seem like you have experience in. You want to talk a little bit about that?
I agree with you. I think data can be pretty intimidating depending on what people make of it and what's the expectation. But typically, it's considered like the gold of the modern digital era. So there's usually a lot of potential in that, and like anything with a lot of potential, sometimes it comes with anxiety for the data teams or those who have to interface with them. But yeah, I've throughout my career, as you pointed out, like at this point, almost the last 2 decades, I've been working at the intersection of machine learning and database systems, essentially pursuing this idea of how we can leverage statistics or AI in general to build smarter data systems, where smarter could mean faster, more scalable, easier to use, easier to deploy, etc. Some of the work we've done is now part of open source transactional databases like MySQL and whatnot, running on millions of servers, but that was all like open source work. Some of the other aspects of my work has been on analytical databases, cloud data warehousing and whatnot. Some of the work we did on approximate query processing, for example, is a good example of combining systems and statistical learning theory that got commercialized and eventually acquired as part of the Snappy Data product. But the latest spin-off is some of the work we're doing now with cloud data warehousing and building a data learning tier. So we've worked at a very high level, like from the insight generation and root cause analysis, all the way to the almost metal of like how to run queries more efficiently at the CPU level, at the GPU level, and the common theme is that it's all fun. Anything that has to do with data, with machine learning, I usually get excited over it. So I could be talking all day about those different aspects, but that's the common theme.
How did you get into it? I mean, I don't think you get very far in the academia. Did you think that maybe when you were a younger student that this would always be an area that was most interesting, or did it fall into your lap one day based off of experiments or labs that you were working on, and this seemed like the most interesting thing?
That's a very good question. It's like most things that you end up liking. It's hard to tell like when it actually started. It's usually so subtle and hard to tell that you can't really tell where it started. But no, actually started my passion was in algorithms. I remember I was always like from early days I was like into math and statistics and figuring out like how many tries it's gonna take to sort of get to a particular outcome with high confidence. So I was always, to be honest with you, I was always intrigued by the power of statistics and like seeing how you can get a lot further ahead in life if you know more about statistics than most people. Like something as simple as like people playing heads or tails, right, with coins. Like if you know what you're doing, you can sort of come up with creative ways. But no, I think a lot of it started when I went to grad school. I started my PhD program with my advisor was a legend in relational database systems, but then he was also seeing the potential. At the time, he was like data mining was the hot thing, right? And then that was the foray into statistics, and then like later applied machine learning theory. It was a progression, and I think the trends that we were seeing in the industry was also helping with that. But to your point, like there's a lot of people in academia who are just kind of content with just coming up with cool ideas that just remain as that. They're ideas and they'll always remain as ideas. But I was always like, left a little bit disappointed that an idea that I thought, hey, has a lot of potential would never make it to production systems. So a lot of what I did earlier in my career was working with industry partners, partnering with different companies and trying to get adoption for free. Some of it we open sourced, got massive adoption, but some of it was like pulling teeth to go and convince a bureaucratic enterprise like why this is in your best interest to adopt it. And by the way, we don't expect any money from you in return. I'm just driven by the impact, right? But at some point you realize, look, you got to put your mouth where your money where your mouth is, and at some point, like a lot of entrepreneurs realize, like, hey, an idea is nice, but like it's the execution that matters, and then you just spin it off, and that's how I started commercializing some of these ideas with the main motivation of sort of closing that gap between the theory and practice, like something that's solid and works, but getting into a place that's consumable by data teams, by products, has a real world impact. So I think that's where a lot of that early interest evolved into.
I think that's really interesting that you were able to kind of bridge the gap between research and academia and getting to really build stuff, because I think that's a tough one. That's a tough one for people who are in academia and get kind of frustrated by the process and, for the reasons that you described, to figure out what to do. And I think most people just end up jumping ship to industry. So
no, that's true.
That's really cool that you could find a bridge there.
Yeah, I won't lie to you. It's not as easy. A lot of people fall off that bridge as they try to cross that bridge. A lot of them fall into the water.
I'm one of those people. It's okay.
I think what happens is that, like in academia, we have this system which is kind of designed. How should I say this? It's designed to kind of reward complexity, right? And if an idea works but it's simple, it's not as rewarded. I remember we came up with this algorithm that was improving the average performance of queries by a significant margin. I forgot the number, but it was something like close to an order of magnitude. And then we submitted this paper to this extremely prestigious conference, academic conference. I won't mention the conference name so people don't get offended. It's the top conference in our area. And then the feedback, one of the reviewers, their feedback was like, hey, if this was an important thing, someone else would have done it by now. And that just kind of rubbed me the wrong way. And I was like, if we go with that mindset, nothing gets done. Because if you either say, hey, this is just, if you take that idea and actually apply it to life, nothing gets done. Because anything that you do, people can say, hey, if this was an important enough problem, someone else would have solved it before. So that actually kind of encouraged us and motivated us in the right way, where we sort of took an extra mile. I remember two of my PhD students at the time, they worked with the open source community. They went there and they said, hey, you guys have this transaction scheduling algorithm. We have a smarter version of it. We've worked on it in an academic setting, but here's why it's significantly more performant. We just want you to consider making this an option. So kudos to those open source developers in the MySQL community. They went and they did their own research. They tried our idea. They came back. They said, this is so much better than what our default is. We're not going to add it as an option. We're going to make this the new default and make the existing algorithm an option. So then the next time around, we submitted that same paper, exact same algorithm, exact same result. And we said, hey, by the way, it is pretty important because now more than 2 million servers in the world are using this as their default algorithm. And that's just one example. There's a lot of good ideas that get killed. But then again, there's a lot of important but boring problems in the industry as well. Like, for the lack of a better term, sometimes to make something work, you have to put up with doing 90% of work that's not boring so that you can actually get a kick out of that 10% that's exciting to you and just complete that puzzle. So I think it's just a fine balance between finding problems that are I used to tell my former PhD students that, when you pick a problem, you need to ask 3 questions. Is it important enough? Do you have the skills to solve it? And do you have what it takes to get it in the right hands? So I think if you sort of look at those 3 problems, holistically, you can find your way from interesting, innovative, highly technical ideas, and then still have a real world impact.
I mean, that's
You
I
need some
I
spite too. All my favorite stories feature like a bit of, like just that little bit of spite and petty. I think it's such a human motivator.
It
I,
is.
I'm surprised though, because like a lot of conferences that I applied to, I don't get any advice back. But I feel like the feedback of someone would have done that already if it was meaningful. What is that? Like, what is the purpose of saying those words? It's sort of like you're driving like, oh, you can only go from spite there, and I feel like that's not a necessarily good place to be driven from realistically. Like, why wouldn't they say like, be specific, like, hey, it'd be great if it was being used in the industry already, like if this is so ingenious, if this is so great, examples
That's
of
fair.
it.
And I think, like, if you look at sort of how how academics excel, right? The idea is you want to find out what others have done, and you just need to do something better than that. And it doesn't matter if that problem is actually realistic, if the assumptions are realistic. It has to be innovative, right? Like if it's a simple idea. I mean, the example I can give you is Spark, right? Apache Spark. A lot of your audience are probably familiar with it. So the initial idea was pretty small, pretty simple. You have you have a working set, you have a data set that you want to, keep doing the same computation on it. So in the, back in the day, Hadoop days, right? Like for those of your audience who still remember, like you had to basically take that intermediate result, write it back to disk, and then if it was an iterative computation, only to read it back into main memory immediately after you've written. So there's a lot of redundant I/O that's just wasted. And the authors of that Spark paper were actually my lab mates when I was at UC Berkeley. And the observation was pretty simple but very meaningful, that hey, if you have a piece of data that you have to do some iterative computation on it, let's keep it in memory, pin it in memory so you can finish those iterations, and then we can, write it back to disk. The idea is sound, it makes perfect sense, well motivated, very practical, but they had a very hard time publishing that paper in academia, because I remember the early feedbacks on their paper was like, this idea is not novel enough. The keyword they use is novel enough, which means like it's too simple. Like, can you add a twist to it? Can you, as if like it's a movie, right? Like you don't want to be able to see the end of the ending, like from the beginning. So that's the kind of mindset that's there, and I think there's good and bad to it as well. Like that's how people become more creative. People learn how to take on open-ended problems. I think academia does a lot of things really well, but there's certain areas where I think closer partnership with actual customers helps save a lot of smart brains from burning their calories on problems that no one cares about, or solutions that no one will actually ever adopt.
So maybe to Jillian's point, what's the benefit of staying in academia?
Oh, that's a very good question. I think academia has certain things that you only get in academia. Like you have access to extremely smart talent, and like as they say, when you hang out with smart people, you also keep getting smarter too, right? And there's some truth to it, right? Like there's, it's not, you can't go and like, let's say you have how should I say this? Like when you're operating on venture capital, there's a very specific timeline. There's a certain amount of risk that's encouraged to take, right? But like, let's say that you're working on curing cancer, like people have been working on it for a long time. Like, incremental ideas will only lead to incremental results. So at some point you need to take some risk. You need to explore solutions that are so crazy, there's a good chance they're not going to pan out, right? And for doing that, you need a little bit of patience. That's hard to find outside academia. You need highly motivated, highly smart individuals at the beginning of their career with that intellectual freedom to go and venture out, find those problems, explore those crazy ideas. And for every 10 crazy idea we try out, one of them is going to pan out, and that's a really good outcome for academia. In the industry, if you go to your backer, to your board, to your boss, whoever that is, and tell them, hey, I need you to give me 10 times more time because I want to try out 10 crazy ideas. It's a high risk, high reward thing. By the time you're to your, third iteration, you're gonna then you're probably going to be terminated or have some difficult performance conversations. So there's a time and place for both, right? If you're looking for really creative, really impactful ideas, to give you a very concrete example, like at Kibo, which is the startup that I'm leading now, we're very successful. One of the main things that people love about our product is that it takes 30 minutes, and then with 30 minutes of investment from your side, the AI kicks in, starts optimizing your cloud data warehouse, for example, your Snowflake, and within 24 hours, you're seeing on average a 25-30% cut to your overall Snowflake bill, which is very meaningful. Like, we have organizations or customers who are spending millions of dollars on their Snowflake. Now, a lot of people are impressed, like, how did you guys build something that's so autonomous, works so well and whatnot? Because it's, seemingly from outsider's perspective, it's very difficult to build that exclusively in the industry. But like what people forget is like, hey, there's decades of other ideas that failed that people learn and they have all this know-how from academia, and then when you finally see the final result, it feels very sudden. Same thing that you see with Gen AI. For a lot of people who are not on the academic side of it, it felt like, oh, there was a sudden breakthrough. But it wasn't a sudden breakthrough. It was, 2 decades of constant work. People were publishing papers after papers and pushing this, pushing the boundaries of what's possible until it got to a point where everyone could see the benefit. So I think that's the other side of it that I just want your audience to be aware of.
I definitely want to dive into that. But the duality is really interesting that you brought up, that in academia, having ideas that really have a business impact, and maybe more than that, have a world impact, are not paid attention to as much. Like, it's just do a little bit better than what you're doing and experiment a lot. Whereas in business, everything has to be immediately relevant. But on the flip side, that means that we aren't getting the time outside of academia to experiment effectively. That teams should actually be experimenting because they may find a way to drastically increase the query speed or performance, resource usage of their database clusters. But on the flip, and so I think it's what you're saying is really both areas that are separate need to learn from each other. More experimentation in the private space, and in academia, more attention to like what's relevant in the next 1 to 10 years that has a business impact. That where the industry is going, what's relevant for them. Otherwise, an idea is just really an idea, and it's not going to get accepted into any conference talk.
No, I think that's a good way of summing it up. I think the kind of balance I found is very useful is like you find real world problems by definition in the industry. You can't go sit in your closet in academia and just say, hey, I think this is a really interesting problem to solve. You can find interesting problems, by the way. You don't need to talk to people to find interesting problems. But to find meaningful, impactful, important problems, you do need to talk to customers, you need to talk to actual users, and that has to come exclusively, in my biased mind, from the industry. And then there's different types of solutions. Like if you want something really out of the box, open-ended, out of the box kind of solution for an open-ended problem, there's a lot of sharp minds in academia that if they're provided with, number one, real-world problems or well-motivated, real-world motivated problems, and a set of constraints that need to be accounted for when designing, that solution, coming up with that solution that otherwise, the people who had that problem would not adopt that solution, then you can sort of expect amazing results from working with academics. So I agree with you. I think like the problem has to come from industry and so should the constraints. But then the solution space, like either academia or people who've sort of had that training, a lot of people, a lot of engineers have never had that opportunity, or they've never been given that opportunity to take on open-ended problems and be given the guidance and mentorship that a lot of professors offer their students who become professors who offer this to their own students and so on. So there's a lot of wisdom about how to approach research and how to come up with creative, meaningful solutions that I think the industry could also benefit from.
I mean, I think in the industry, we actually have this counter perspective, which now seems like it actually has a lot of paradoxical negatives. I hear very frequently, hit the ground running, like setting up onboarding docs and tooling and resources so that you can just get started on your first day working at a new organization and a new company, and you just already know how it's supposed to work and already start providing value. And now I'm getting the thought of like, well, actually spending time learning the backwards way that an organization is working before you actually start delivering value may be an opportunity that we've squandered in a desire to move quickly and get everyone on the same page as fast as possible. There's a much lower opportunity for learning and I'd say failure, which I think a lot of people agree is a strategy that really drives future innovation.
No, that's right. I think, another way to look at it is, I think there's nothing wrong with moving fast. Like, that's the thing. That's my own motto. Like whether I'm working in an academic setting or in at Kibo, like we want to move fast. But sometimes people have the perception of moving fast, right? Sometimes if you're building a house but you're not taking the time to really understand the measurements and what you're doing, and one side of the wall is shorter than the other side, you're not really fast because all that work is going to be throwaway work. So I think the right speed is actually failing fast, because you can't know everything. If you one of the things I've actually seen that's quite prevalent across the board, especially with more junior engineers, is that desire to be a perfectionist. People try to we used to have a senior engineer who used to refer to that as premature optimization. People have a tendency, especially in earlier years of their career, to try to perfect things way too early, way before it's even proven to have any value, right? Like, I'm usually for the quickest, dirtiest, hackiest thing to prototype something and see if it holds water. And if it doesn't, that's perfect. That's called failing fast, because guess what? You didn't spend a whole year building it. You spent a sprint, 2 sprints, trying it out. And now that you failed, you just ruled out one of the ways to fail. And I strongly believe that the number of ways to fail is finite. So as long as you continue to fail, but very quickly, you're guaranteed to find the path to success.
I sort of want to go back. It's been mulling over my head about your AI agent that runs to reduce your Snowflake costs. How does this actually work? Like, how does it just go in and like, is it reducing, is it finding, is it deduplicating data? Is it improving query search performance? Is there some other magic going on?
So here's the like, to sort of see how it works. I think it might be useful to your audience to think about like the bigger problem, right? So like, one of the biggest things that's happened in our industry over the last, I would say, decade and a half is like the rise of cloud databases, or in particular, like, the success that the likes of Snowflake, BigQuery, Redshift, and more recently Databricks have seen. And if you think about what's happened there, is that these cloud data warehouses, the likes of Snowflake, have really lowered that adoption barrier, right? So now it's significantly easier for anyone, any organization of any size, any team with any level of skills, to go spin up a cloud data warehouse and start analyzing that data, querying that data, getting that data very quickly, right?
Sure.
So that adoption barrier has gone down. But the byproduct of that, the side effect of that, is that because it's so much easier to leverage data, now you have more users with varying levels of database proficiency and skills writing queries. They're querying more data and they're combining more data sources. So as a result, I would argue that the data pipelines that organizations are dealing with right now are an order, at least if not 2 orders of magnitude, more complicated than what we used to have 15 years ago, right? Because it's just that much easier. You don't have to go through all these hoops to get to your data. Anyone can spin up a cloud data warehouse. And as a result, because it's so much easier to use, they're so much more complicated, and because of that, they're so much harder to optimize manually. Right now, you're dealing with millions of queries. Some of them are coming from this analyst, some of them are coming from this BI tool, some of them is this ETL job that this guy wrote, a year and a half ago, and he's not with the company anymore. And then there's these reporting queries that hit the cloud data warehouse. Someone is doing data science, someone's training their models. We're looking at millions of queries. As someone who spent the last 2 decades of their life, like essentially with database systems, I would be intimidated to stare at some of these queries and figure out how to optimize them. They're just not humanly possible, right? But that's exactly where AI or machine learning really comes to the rescue, because I call this, you can think of Kibo or machine learning algorithms in general as an infinitely competent, infinitely patient DBA, right? You can you can analyze millions of these statistics. Look at, hey, how did these variations in the load correlate with the variations in the cost and performance, right? So for instance, if we just take Snowflake as an example, you have to pick a size for your warehouse, right? You have to decide, for example, what's your partitioning key, right? You have to decide how long you want to keep this warehouse running after the query has finished. If I shut it off right away, well, I saved money. I don't have to pay Snowflake for just keeping an idle warehouse running, because they pay as you go. But then if the next query arrives and my warehouse is shut down, then I have to spin up a cold instance, and now a query that would have taken a couple of seconds otherwise now has to take maybe a couple of minutes because it has to read it off of cold storage. Like, okay, so what's the optimal time to shut down a warehouse? And then this warehouse, most data teams, they say, hey, I need a medium for my, BI workload. I need a large for this. But do you really need a large warehouse 24/7? Is your workload constantly, steadily at a level where it warrants a large? Maybe sometimes you need an X large. Maybe it's actually cheaper to use an X large because you pay more per unit, but then the query finishes, let's say, in less than half the time that it would have otherwise. Maybe it's underutilized. Can you wake up your data team and send and can you page your DevOps team to go and reduce the size of your medium warehouse at 2 a.m. from to a small warehouse, and after 7 minutes wake them up again and say, actually the workload increased again, go back to the default size? You can't do that, but you can actually train reinforcement learning models, for example, to do that, right? So you just...
you can do that. I feel like there's going to be a bunch of very unhappy people at the end of the day, though.
Well, there are things that humans can do, and there are things that humans want to do, right? Like if you find the intersection of what is it that humans cannot do or don't want to do, and you automate that, that's how you've empowered your data team, right? Like I've never met a data engineer who's told me, my dream is to wake up at 2 a.m., reduce the size of a warehouse for 7 minutes, and then go back to sleep, right? Like I've never seen anyone who tells me, I wish I could just squint my eyes and look at 2 million queries and figure out which one should be routed to which warehouse. But the reinforcement learning agent is more than happy to do that. You just have to have the right reward function where you penalize the agent every time that it causes a slowdown, and you basically reward that agent every time that it manages to make some configuration changes or route a query to the right warehouse that actually saves money for that customer without actually impacting their performance. And that's how you can actually save significant amount of money, because there's so much variation in your daily workload, that if you actually know what you're doing, you can build models that significantly save you on cost.
I know it's coming, but I'm still so freaked out by the idea of having these agents that are just doing stuff. I mean, I guess it's not really any different from, your case isn't like that different from an autoscaler, and that's a known problem, but just in general, I'm not there yet. And I really like AI. I think like I'm all about the AI over here, right? But, like,
no, I think you're spot on, Jillian. I think the reason why we've been very successful is because like we address that elephant in the room. Right? Like one of the most common, I think there's actually 4 very common failure patterns with AI in general, with AI adoption, right? One of them is implementation risk, right? Like if you have to convince a team to spend weeks and month iterating with you, doing a POC, learning new things, rewriting their code, then you're already off to a very difficult start. The second risk, I would say, is the adoption risk. Like people being scared of, what if it's here to take my job? What if it slows down? Like I don't want to be yelled at for slowing down your, for telling my boss that, hey, I'm leveraging AI and it made a poor choice in the middle of the night and the pipelines failed. There's the security risk, like, hey, I don't want to have to justify why I'm giving access to this third party to come and train our most precious data. There's pricing risk. This is actually a pretty big risk as well. Like these days, it's a tangent, but we were attending the there was a summit that we were attending, and there was a bunch of different vendors there, and our marketing team made an observation that every single booth had the word AI written on it, even if it had nothing to do with AI. Like, they're just like selling cookies. I'm exaggerating here, but like everyone felt compelled to put AI in their positioning just because it's hyped. And what it's done is that it's bad in two different ways. Number one, it muddies the water, so people can't tell who's actually leveraging AI and who's just using it as a buzzword. But the second thing is that you've got these CIOs who got really excited. They were sold a bill of goods, but then they were let down. They spent all this money and all this time and resources, and at the end, nothing was delivered. So there's that pricing risk. Like, how do I know that this is going to be successful? I'm not just trusting you. So the reason why actually Kibo was able to create these models and get real world adoption and have a lot of happy customers is because we address these four risks like head on. The first example was the implementation risk. Before we even wrote the first line of code, we made this decision that whatever we do should not take more than 30 minutes of one engineer's time to onboard. Right? We used to joke that if we take more than 30 minutes of your time to implement Kibo, we're going to give you an iPad for free. Here I'm sitting talking with you, we've never had to buy a single iPad. The second thing we did was the adoption risk, right? That we told people that our actually internal motto is our first slowdown is our last slowdown. So if you think about an autonomous car, let's say self-driving Tesla, to give you an analogy, if you're a vendor that's building autonomous cars, your first crash is going to be your last crash. You can't just tell people, hey, this is a fully autonomous car, but almost autonomous. It just has a crash 1 in 1,000. It's not good enough. If there's a likelihood of a crash, then you're dead in the water. So what that means from a design perspective is that whenever in our algorithmic work, we had a fork, whenever the agent has a choice to choose between increasing the savings for the customer and protecting performance, we take the latter. Because no one yells at you for why, instead of saving me $102,000, you saved me only $100,000 this month. But if you cause one slowdown that makes their jobs fail and their boss yell at them, then they're never going to trust this thing ever again, right? From a security risk, we made this deliberate decision that we're going to restrict our models to train only on metadata. So we don't even see customer data, right? We train on performance telemetry, all of that. From a pricing risk, we came up with this idea. A lot of people were critical of us, why are you guys making it so hard on yourselves? But we decided, you know what? We're only going to charge customers a percentage of whatever we save them. So our incentives are aligned with customers. No savings, no charge. If we save you $3 million, we take a portion of it. If we save you $3, we take a portion. We save you $0, we take none. Right? So those risks are there. You just have to be really intentional about how you design your software in a way that accounts for those risks and addresses them head on. You can't build something and then figure out, how do I convince customers that those risks are not there? You have to build it with these principles as your guiding principles in your design.
So one of the things that I identified early on with the AI hype bandwagon is I think a lot of companies were using AI on their marketing pages as a proxy for, I don't actually know how to talk about the value our product delivers. So I'm just going to put these two letters on there and pretend that means something to someone, and they'll bring their own ideas about how that could be valuable. And I think before that, we saw similar things happen in the past. I think just the speed and the velocity of change that's happened for the AI cycle has been so fast that it's really easy to see from innovation hitting the market, not outside of academia, because we all know AI has been around for much longer than just the 5 years now. We're going back 20, 30, 40 years where there's lots of papers out there. But in business, realistically, and we can actually see the change from innovation all the way to exploitation. And I still think that we have the same number of companies that are startups or even big giant Fortune 50 companies that honestly have no idea of how to actually convey their value effectively.
No, that's fair, and I think that's a big challenge. I think it goes both ways, right? You've got at the top of the food chain, right, like CIOs and CTOs who hear these buzzwords and they feel like we have to do something about it. The board is asking about it, right? Like, we got to do something about it. And then on the other side of the equation, you've got sometimes ICs who are worried about like their jobs. Like, hey, if we adopt this thing, then what's going to happen to my job? And like my reaction to that usually is like, if you worry that AI is going to take away your job, it's probably going to take away your job, right? Like if you like resisting it, because it's just like laws of physics, right? If you're standing on the wrong side of history, it's just a matter of time, right? Like you cannot, it's happening, right? The best you can do is to sort of empower yourself with more knowledge of how to best leverage it. Like there's a huge market for engineers and DevOps folks who understand AI. They know how to best leverage it. Like, ML ops is a thing, right? Like, how to, like a lot of the machine learning experts that come out of academia don't have the faintest idea of how to deploy something to real world. Like, so like, you need these engineers who can who understand the high level concept, and they can, you can partner them closely with your machine learning researchers and experts to sort of build stuff that can actually get deployed, get trained at large scale, and get trained and have the right level of robustness and reliability. So there's a lot of things that people can do to protect their jobs. Just go take an online class and brush up on your stats class, and take a machine learning course. Try out a few tools that are out there. One of the biggest anti-patterns I'm seeing these days is, which I think has plagued the software industry on the consumer side of things, is this unreasonable urge for building versus for build versus buy. And I think significant amount of engineering cycles are getting wasted by people giving into their own natural instinct of, oh, I just want to build everything in-house. And you'll be surprised, like very few CIOs and leaders are able to sort of tell what's the right time, what's the right thing to build versus buy. And I see people get that wrong all the time.
I liked your call out here on where you should be concerned and how to train yourself or grow further. I mean, the idea that if you fixate on the fact that your job is going to go away, then it probably is, actually really reminisces for me a concept from, of all places, Hawaiian shamanism, which is like, if you fixate on this thing, you are actually bringing it into reality. You are making it the case. And I do really think that manifesting, yeah, for sure. So I do think that there is a lot there. Like if you want to be, like you can figure out what your job should be and what you want to be an expert in and how to achieve that. And maybe it's not a fit for your current company, but for sure, if you just worry about the fact your job may or may not be going away, there's definitely an aspect of, and this is something that I've picked up recently and I've been trying to live by. It's not necessarily the easiest thing, but I think it's an ancient Confucius wisdom here that if you worry about the future, then you cry twice. You feel the pain twice. Right? There's something you can do about it right now, and rather than worry about a future that probably won't even come, do that thing. And if it does come, then you're at least prepared.
No, 100%. No, 100% agree.
I'm sort of curious about the verticals that you see. I mean, we talk about data intensive systems a lot, and like what falls into that category, like
what
concrete
kind of
things. Yeah, what kind of data?
One of the interesting things that again has happened with the rise of, I mean, there's a reason why Snowflake had one of the largest software IPO ever. One of the things that this new breed of technology has actually, one of the changes that it's made in the way that data is being consumed is that it's become, number one, size agnostic. Like back in the day, if you were a bigger company, you had more data. And if you were a smaller company, you probably had small data. And then there were certain industries that were like, tech was known to be like, much more data savvy than, for example, government, or, healthcare was a lot more protective of their data. And, there was certain segments or sectors of the industry that were more data driven. I think what we're seeing is that it's penetrating everywhere. like I was talking to a local government in one of the states where you wouldn't think they would be looking at Snowflake, and they're like, no, we gotta get on that. We gotta get on that, cloud data warehouse for these 5 reasons. This is what this is what we're trying to do. I was like, do you guys even have the budget for it? I was like, but that's irrelevant. We gotta do it for these reasons, and then. So that's from a sector perspective. But the other thing, which I think is even more interesting, even from a sales and go-to-market perspective, is that you have no idea how much a customer is going to spending on their data infrastructure by looking at the size of that company. Kibo has customers who are spending north of 15 and more $1 million a year just on their Snowflake bill, and they're a tiny company. Like, not like 2 or 3 people, but they're less than 500 employees. And then we're basically working with like these massive multinational grocery stores where the entire cloud data warehouse bill is only $200,000, right? So I think that's interesting to see both directions. Like the data is growing vertically, but also horizontally across these different sectors. I wish I could give you an easier answer, say, oh, it's only fintech and retail, that's where we're seeing all this thing. But it's not. Like, we're seeing it in healthcare, we're seeing it in government, we're seeing it in all sorts of verticals. And the only common denominator is that companies have realized that they need data-driven decisions. They've realized that they either have the data or they have part of the data, and they have to go and acquire other data, whether from their CRM, from their marketing tool, from their website traffic, from third-party vendors. There was this insane, I don't want to misquote this thing, but there was this insane report I read lately which was saying that average, companies now on average combine X number of data sources. And X was an insane number. It's like one of those numbers you're even embarrassed to quote. I think it was definitely north of 20. And it's insane if you think about it. Like, that's a lot of complexity right there, right? Like, companies should not have to deal with this with their own resources. If you're a bank, you got to focus on what's making you a differentiated bank. If you're a marketing company, you have to focus on your core business. You shouldn't be in the business of building and optimizing your own data infrastructure. You gotta automate that part too.
I think part of the problem here is, I think it's sourced from humanity, this idea that growth equals good, and that your total addressable market can actually increase in size over time, and you can make it happen. And these companies are lacking ways of growing still just a little bit bigger, and so they're spending a non-trivial amount of money pulling in almost nonsensical data, nonsensical sources, things that aren't so relevant, in order to even increase their market share by percent, like pips, hundreds of percentage points, because that's all they can do. But if you realize that your market is only so big and that's it, you know where you should optimize for, and potentially just stop there. Focus on cost reduction, on optimizations in what you're doing, rather than trying to add yet another product or another feature or service in a way that doesn't really add fundamental value to your users. You actually opened you stepped in this and you opened the door, and I want to ask you about this. I feel like since the exploitation of LLMs and the data that we have that's been created since the internet was conceived as an idea, we're losing public access data, like the data sets that are available just from scraping individual websites or just freely available, I think is actually decreasing. I dare say that the end of the internet has come, or it's on its way, that connectivity is no longer what we're optimizing for. And I'm wondering where you see this going. Is it private data sets that are curated and data brokers? I know that Cloudflare has jumped up and down and said, hey, look, we can do this. We're already blocking bots, and we know what data is being transferred and who has websites on our platform. We will sell you this data, AI scrapers, that you can go purchase from the data sources. Is that the future?
I think people are going to move on. It's hard to predict the future, but it's also easy because no one's going to remember to come back and hold you accountable for misprediction. So I want to call that out. But I think if we're, within the next decade, I usually have the thing is, like, if you spend too much time any particular area, you can see things that are pretty obvious to you, but maybe they sound weird to others who've not been following that thing. For a lot of things that might be a surprise to others. For example, like the success that ChatGPT had was a surprise to a lot of others, but not to those who were tracking the progress like over the years. So I think in terms of data and selling data as an asset, I think we're actually already moving past that, right? Now people are selling agents that are trained on that data, right? Like, there is a reason why there's all this, excitement about, like you guys have seen the news about DeepSeek and what it means for, the use of GPUs and like, the investments that companies like OpenAI have done. But the bottom line is that there's an arms race. Like you basically train these AI agents instead of having companies sort of just go and purchase this data and then clean the data and then combine the data and then build apps on it and then monetize it and then maintain it and tune it. Like you just buy these agents. I think we're past selling data and we're at the place where we're selling agents that are already trained and ready to be deployed.
If the data goes private, though, no new agents are going to be able to be spun up. So, from that standpoint, we're at the road's end of where the AI innovation can take us. I feel like fundamentally, in order to keep evolving and innovating, we still need new, fresh sources of data with combining all of the humanity's collection so far in order to actually train on all of it and get the most effective agent being built. Or is I'm missing something here?
I mean, in theory, but if you think about it, the majority of the humanity, their data is actually held by a minority of humanity, right? There's like 2-3 big players. Like, I mean, that's the almost sad part of like how consolidation has been working. Like, you have 2 or 3 major providers who are seeing and recording and monitoring 99% of
what is that, like Reddit, Stack Overflow? Like, what's the third one?
I don't want to get into talent for coding, but like, I mean, if you think about like, Google doesn't need me to send them a copy of my hard drive. Like, they see my emails, they see basically my usage pattern on my Android. They see like the content that I'm consuming. They see the books that I'm basically searching for. Amazon knows the items I'm buying. They're looking at every book that I'm reading. Like, they have a lot of this data that, at least in the US, like I can't speak for Europe, I think they have much better laws when it comes to privacy protection. You don't even think twice about, clicking and saying, I agree to these terms of use. And I think they have the majority of that data. Like, will we be better off if everyone shares everything and then we build this stuff? I don't know. I think it easily gets into the area of security and privacy, which I don't know anything about. But I think if that was not a concern, probably the answer would be yes. But I know that is a concern. But I also know that there's very few players who who have already plenty of data. I mean, OpenAI has the data that they're actually scraping, but is it going to plateau? Probably there's going to be, I think these things are going to become a commodity. These agents will become a commodity. The arms race will not continue, and then we'll move on to the next thing after that.
Well, that's an interesting point. Maybe there's this idea in biology where you just need a limited set of unique individuals in order to propagate the species without too many mutations, of which it will collapse under inbreeding, basically. Like, maybe there is some set of data that we only need that much in order to uniquely be able to create even the best trained agents that we possibly can. Additional data won't help us in that way, and maybe we've gotten that. Maybe we'll get it.
That's actually the crux of learning theory, right? That basically the error will go down, 1 over n, when n is the size of your data set, right? Like, so that basically means more data at some point is not going to significantly reduce. More training data will not significantly reduce your error. Obviously, that depends on the sparsity of the data, the whole idea behind VC dimension and whatnot. But the main idea is this, like, I know we're not really good at particularly, predicting election outcomes, but the idea of like these election surveys is exactly the same thing, that you don't need to go and ask every 300, every one of the 300 million voters. If you have a sample that's large enough, past that, you're not going to significantly increase the accuracy. I think that's definitely true, that there's a diminishing return. It doesn't mean more data is not going to help. It means that there's a diminishing return.
I can't see Jillian, and I think that means she has some secret questions that she's just trying to figure out how to put into words.
Yeah, because I kept freezing when I had my camera on, so I thought that I'd turn it off for a little bit. Yeah, I definitely agree with you guys on the, like, you can keep adding more data, and that doesn't necessarily make it better, but we're also always getting new data. Like, we're always producing, like, new and different data, and we need the new and different data, too. So I work with, like, a lot of medical data, and we're kind of constantly changing just everything, the resolution that we can, see the data at, the amount, just more insights, more everything. So I don't know. I have very mixed feelings about this because I've definitely been on projects where we've been like, where somebody's been pushing more to like, well, just make it better. Can't you just add more data? And I'm like, no, you see the last 3 data sets that we added to train it, they didn't actually do anything. Like, here's the graph. And then they're like, more data. And I'm like, well, you're my boss. So like, okay, but this is silly.
I mean, I'm with you. And I also think that the medical industry, that vertical, is actually more unique in this way. I think our lack of full understanding of even our human bodies, but organic material organisms in general, means that we could benefit from having more data there realistically. And I feel like there's so many things that we haven't figured out there. The other verticals I question a lot. Like, I've worked, I think, at 5 different companies now in total, separate from all of the consulting that I've done and advising. And all of them were like, our data is precious. We must save all of it. And I'm like, you don't need that data from 10 years ago where you were measuring the deviation on vibration tests of this one product that you don't even manufacture anymore. Like, I assure you can throw that away. It's not going to help you. And yet they're like, we got to keep it. I'm like, okay, AWS, Glacier. Yeah.
Well, storage is cheap, right? But I mean, you're right, to your point. I mean, medical data, I remember I was working with one of my colleagues from the med school, and we were trying to predict, he was a cardiologist, and we're trying to train models that predict the chances of an organ after I forgot the
transplant.
Medical term, like, when they basically do an organ transfer, the body, the host body, there's a chance that it might reject that organ, and they use antibiotics or whatever to suppress the immunity system and whatnot. And there's complications, all of that. And the idea was to predict the risk of an organ rejection. It's called transplant.
Transplant.
Yeah, transplant. I think that's a medical term for it. But I remember, they were saying, like, at UMich we have one of the largest cancer data sets on the planet. And then when we looked at it, it was a number that, like, I forgot the exact number, but it was something like close to 300. And I was like, how is this the largest data set on planet? It's just like medical data by definition is way more sparse because there's only, 6 billion or 7 billion cap on how many you can collect. And for any particular disease, there's a very small subset of them you have access to. So I don't think the laws of large numbers do apply to anything that's about, I mean, with DNA and stuff, that's different. But when we talk about individual humans as data points, I agree. I think that's probably an exception. I don't think we're at the place where we don't need more data.
I mean,
we need the data science companies to just go sit off in like a corner for this conversation when we're talking about like building agents off of data and how much data should we have and when do we stop, because like medical data, climatology, I don't think the answer is ever, or not right now anyways, not any that I can see.
Yeah, I mean, I'm with you. I think the problem in the medical field, though, is that it's not public. I feel like the climate data and tracking, like, there's a lot out there. Whereas in the medical field, like, that's controlled by private entities who are bound by local regulations on even sharing that, which is in a ridiculous way. And the data, there are companies out there that do anonymized data exchange in the medical field specifically to sort of help overcome this problem. And like, there's not a benefit for the patients, there's not a benefit for the providers, for the government. Like, there's very little benefit here except the end company who may be able to use all this for the good of humanity. And that's a hard sell, I think, when there's dollars on the table on the other side.
And a lot of medical data is supposed to, like, if it's used for research, it is supposed to be public. I mean, it's not always, or it's maybe not in like organized in such a way that it's even usable, or like there's a lot that can go wrong with that. But there is supposed to be a lot of medical data that's public.
Well, I think part of it is legacy systems that aren't optimized for even storing the data in a electric medical record format. Like if it's not electronic, you end up, before we were talking about hallucinations in the world, which is still something AI focuses. We had the giraffe problem, where looking at an image from a medical document would likely render positive on whatever the diagnosis is that you were trying to track, just from the existence of uh, uh, ruler, or the way that, because it was an x-ray, or things that had nothing to do with the actual information that was contained in the document. So I don't know. I'm with you. More data in the medical field for sure. Anyone who's working on that, like, don't stop.
Always more data. Yeah, I don't know. Storing biological data is like such a problem too, but that's probably another that's another topic for another show, I think.
Well, now you've got me.
For a lot of like the cloud things, we could probably have AI agents, because a lot of it is probably autoscaler problems. But I think doesn't AWS kind of shut a lot of those down? Like I was talking to, I forget what, like a vendor through a client, and they told me like, yeah, AWS basically made our like business model obsolete because we're trying to save money. Although this is a lot of hearsay, so I'm not sure that I should be repeating this. But anyways, it did seem like they had something where they had like agents or AI running around in the background to try to cut down on costs, and it was not well received.
I mean, if you build something on a hyperscaler, there is a chance that they will find a way to recapture that value and claim it for themselves. Like if every one of your customers needs to do something, it benefits everyone to bring that value that you can deliver back into the platform. So I know AWS is actually pretty good about doing that, rather than forcing everyone to use a third-party company to achieve the same benefit. Like, it's surprising to me that companies like Snowflake or Databricks, and there's a couple other ones out there. I think Datadog's another good example. There's companies that just sit around and help customers spend less money on these platforms. And if that was me, like if I'm Snowflake or Datadog, I'm just like, okay, I think it was like Coinbase was spending almost $100 million a year on just data analytics coming from their platform, and they weren't very big when this got reported. And then they're like, we're going to have to do something about this because that's apparently too much money, and that is a lot of money to be spending on it. Mm-hmm. It's just a bit ridiculous, because if lots of customers have this problem, like you would think that lowering the price point in some way, not by changing your pricing, but by doing those optimizations, helps all of your customers in some way. Otherwise, they're just like, otherwise they're going to pay a third-party company to help them do the same thing anyway. So I think over time, as you get more and more customers who all have similar problems, they have no choice but to bring that effort in-house, either by buying a company that is doing that for them or spinning up their own internal version of it to optimize.
I think there's two parts to it. One of it is like, why would a big vendor invest in reducing their own revenue, right? Like, Snowflake's stock price is a function of their revenue, right? And if they want to reduce their own profit margin or actively be in the business of reducing their own revenue, I think that will not go very well with the shareholders. But the other part is like focus, right? Like, as a vendor, you always have to protect the main body of your revenue. Like, this is like the innovator's dilemma, right? Like that you have to, like, you can't work on niche opportunities. Like, your job is to build a database that anyone on the planet can use, right? Now, what's going to optimize this kind of workload might be different than what's going to optimize this other customer's particular use case. And that's where I think startups excel a lot. But I agree. I think they also realize that if there is a reason why, like, we're partners with Snowflake. There is a reason, is because there is a reason for this. Like, they see value in us serving their customers almost in a unpaid customer success capacity. I call ourselves, I sometimes joke that Kibo is Snowflake's unpaid customer success department, because like we prevent their customers from churning, right? Like, at the end of the day, if I'm spending a lot of money and I'm not able to get all my use cases onboarded, and I'm under pressure, and the CFO is yelling at me, I'm gonna look outside. So Kibo is helping customer get a better performance per dollar for the budget that they have. So I think there's also that bigger picture. Although sometimes the sales reps don't share that same compassion.
No, I mean,
They're thinking one quarter at a time, right?
Yep. Yeah, I think that's the biggest problem. If you look at the brand of a large data company or even any large company, you have to look out multiple years. And you're absolutely right. Like the value that you're providing them as part of the Snowflake network is higher than the amount that it would cost them to maintain that same piece of functionality internally, or the amount of revenue that they would lose if, say, all their customers had access to that functionality just straight away, or it was automated in some way. So, I mean, if you look at that equation, then realistically, you want the network to be, you want everyone to be happy in a way. And so if what makes them happy is that there's little startups out there that are helping them reduce their bill a little bit, then you let that be the case.
Yeah,
I mean,
absolutely.
the economics obviously change at larger scale when all of your customers have this problem, or they're all unhappy because of how it's going. So I think we're about at the hour now, and I feel like this is a good point to maybe say, like, okay, is there maybe one last thing that you just want to share? You feel like maybe we didn't touch on that could be an interesting topic, something to close out the episode with?
I think when it comes to software design, one of the things I've sort of recently seen it explained very well is sometimes technical people like to have a lot of knobs, because we usually think more flexibility means more options, means better adoption and all of that stuff. I think one of the things we've learned the hardware is that actually the fewer choices you give people, the more likely they'll make you'll get adoption, right? There's this week I read this somewhere, and it was summarized pretty well. I think apparently there was a very successful shoe salesman in LA back in the 50s, and they interviewed him and asked him, like, what's your secret? And he said, my secret is the law of 2, not 3. And they asked him, what you mean by that? Is like, whenever a customer asks me to bring down a shoe so they can try, and then they ask for a second one, I give them to them. I give those shoes to the customer as well. But if they ask for a third pair, then I tell them, which of these 2 would you like me to put away? And the reason is they figured out that when they give customers 2 choices, if they give customers 3 choices or more, they're likely to buy none. But when they give them 2 choices, they're likely to pick one. And I think that actually applies in some really profound ways to software design and AI adoption. If you basically overwhelm people with like 20 different knobs, then essentially you're sending this message that I don't know how to tune this for you. I'm throwing all of this over the wall. You have to figure it out. And by the way, if you get any of them wrong and things go sideways, you have to own that decision. But if you can simplify that, you get a lot better adoption. Like in our like for example at Kibo, we give a slider to customers where they can choose between best performance, good performance, balance, high savings, highest savings, right? These are things that are not, they all turn into a vector, a bunch of numbers and relational linear algebra and all these operations. But like, we give these high level things to customers, and 99% of the time we actually get better adoption with it. So I just thought like this was an interesting quote from this shoe salesman from 50s, where what is it now, 75 years later, a lot of us still overlook in software design. I thought it's an interesting observation to share.
Yeah, I also forget that we're in the 20s now of 2000. So when doing math for last century, that still trips me up. No, I think that's a really great point. I think it's a really interesting perspective there, which goes in the direction of developer experience and user experience for not just selling the product, but making sure people actually understand what they're doing. And there is an aspect of decision paralysis there that really drives into what people are going to do or how they're going to use the tool effectively. Okay, well then, Jillian, should we move on to picks?
Sure.
What do you got for us today?
I'm gonna pick Infinity Nikki. It's a video game, and it's just this open world game where you just you just run around and you just try on pretty dresses, and it's nice, and it has very like satisfying mechanics of jumping off buildings. That's it. That's the game. I think there is actually more that you could do in the game, but there's not more that I'm going to do in the game, so that's like the extent of my knowledge.
I think what everyone needs an answer to is how much AI is in the game.
I don't know. I think it's all procedurally generated. I don't think it has like any AI anything.
So you're saying is there's some future DLC for the game studio that's coming?
Maybe. I have been wondering like if video games are going to start to make NPCs, like if they'll just have them just have like agents and or not agents, but those will all be AI. So then you could, I don't know what, ask it for a cake recipe or something. But like that does seem like some low-hanging fruit for the video game industry is to just do that. But I don't know if it would be like cost-effective rather than just have a script.
Yeah, I was gonna say, the video game industry, notoriously super high margins and lots of extra capital to spend.
Yeah, they do. I don't know. So I don't see it happening there, but maybe it'll come up someplace else. Yeah, because video games are interesting because like everything else can be procedurally generated. So I don't know where you would put AI.
I mean, I know some people that are using the foundational models that are out there to sort of make single player games out of as for engagement and getting them to either basically DM you or be the game master for you as you sort of play the game. So things that would have normally required multiple other people, turning it into a single person experience. So I think it's possible, but yeah, I think the cost is going to be okay. I like that pick. Barzan, what do you got for us?
An interesting book, I think, that I would probably recommend. It's not really related to engineering, but I read a lot of books, so I really love books this much. But I think this is one of the good ones. It's called Never Split the Difference. It's
Chris Voss, yes.
Have you read that book? It's amazing. It just talks about the different characters of people, like when it comes to negotiations. Like, it talks about you've got the analyst, you've got the negotiator, and then you've got the accommodator. And if you're basically, you got the assertive type, right? So if you're an accommodator and you talk to an assertive person, you're just giving them an opportunity to socialize with you, and that's just offending them and things of that sort. So I thought it was pretty interesting, like a lot of those things where you kind of learn from muscle memory, and I think if you sort of be more intentional about it, it just makes you a lot more effective in day-to-day communications anyways, not just in negotiations. So I thought it was an interesting book that I recommend to.
No, I actually really liked it. One of the things that I took away from it, really importantly, that's helped me a lot, is to understand I always thought the idea of like a win-win scenario was made up nonsense. But the way he puts it in the book is that you're optimizing for certain things and the other person's optimizing for different things. And you can both optimize for the things that you want, as long as you make that information public and you share it and you converse about that. As long as you keep it hidden and secret, then you can't ever really get the other person to move on that potentially. So I think about like salary negotiations and engineering. I don't have them at my company for engineers that we hire. We don't just say like, hey, this is how much you get. If someone wants more money, we have a conversation about like, what is that expectation that comes with the change in salary? It makes sense to talk about that. If you want this, then there's this other part that's important for us. Like, for instance, people that want to be, say, a senior engineer, and we think they're more at just the engineer level 2 level, we would say like, well, there's higher expectations. And that means that if you don't meet these expectations, there's a greater chance that we'll have to either reduce your level in the future or we'll have to let you go. So, is that a risk that you want to take? Increased risk for increased reward potentially. No, I really like the book. So
they talk about like the idea of the example they say, like one of the examples they give about this win-win situation is like if you have a hostage situation where they have 4 hostages and you say, hey, they threaten to kill all 4 of them. You say, how about meet in the middle, and you only kill 2. It's like it says like this idea of meeting in the middle is ridiculous. Like it doesn't work that way. You really need to know what is the outcome you're driving towards, and I think there's a lot of interesting takeaways from that book, like the one that you mentioned.
Yeah, I mean, Yeah, no, I think it's great. It's a great pick. My pick today is going to be the L8 conference, which this year was in Warsaw, and I just got back from speaking at. I did a short talk about building highly reliable software and why having 5 nines is nearly impossible, more so than anyone thinks. So. If the LA conference is in your area and you're thinking about where to go, also highly recommend this one along with what I said last week. So that's it for today's episode. I want to thank Barzan for coming as our guest, and I want to thank the audience and all our viewers for listening to this episode of the podcast. And that's it. And have a good rest of your week until next time.